Our mobile phone touch screens do use the phenomenon known as capacitance. We will try and understand what is capacitance and the capacitor in general. The capacitor, as shown over here, is made out of two different metallic plates. So there is a plate A taken on the left hand side and there is a plate B on the other side. Now these two different plates, two different metallic plates, will be storing some different charges. So let's say on plate A we have got positive charges and on the plate B we have got some negative charges. And let us suppose that the distance between these two plates is represented by small d. So in this case, these two plates, they happen to be storing different charges and different in nature. That is, one plate is storing positive and the other plate is storing negative charges. And the distance between these two plates, that is this distance, is small d, represented by small d. And let us suppose that the area that it covers, both the plates are having the area represented by capital A. In this case, we would see that the capacitance, the formula of capacitance would be C equal to epsilon A divided by D. This is the basic formula of capacitance for any capacitor which is a parallel plate capacitor. Here we have got two parallel plates, one is plate A and the other one is plate B, and for the same we have got the capacitor formula, capacitance formula as C is equal to epsilon A by D. So using this formula and even otherwise, we would realize that closer the plates to each other, that is less the distance between two plates, more would be the capacitance. And farther the plates, that is more the distance between these two plates, less would be the capacitance. If we take area, then more the area or greater the area, better would be the capacitance or higher would be the capacitance. Lesser the area of plates, lesser would be the capacitance. It all turns down to the amount of charges that are stored over the plates. So as we see over here, if the area would be bigger, more would be the amount of charges stored on these plates. More would be the capacity of these plates to store the charges because of higher surface area. So if more number of charges are accumulated on these plates, then it would be giving us higher amount of capacitance. The other formula of capacitance, C, is also C is equal to capital Q divided by V, that is the charge per voltage, and this over here, the one in green, are the charges. We can represent these charges by capital Q. So charges per voltage gives us the capacitance, and this epsilon, it represents permittivity. Permittivity is related to the permit. Permit in a way means allowing something to pass through it. So the medium in between these two plates is known as dielectric medium. So the dielectric medium will restrict the charges from moving from one plate to the other. However, it will allow the electric field lines to pass through it. Electric field lines, just like the magnetic field lines that we have in the magnet, we have got electric field lines that are passing from positive charge and moving towards negative charge. So over here in this example, since we have got 9 positive charges and 9 negative charges, this is just an example. There are trillions and billions of such charges and trillions and billions of such electric field lines. So these electric field lines, they pass from positive, they move from positive and they end towards negative. So over here, there are 9 such lines passing through this medium which is between these two plates, and this happens to be the dielectric medium, which will restrict the charges from passing from one plate to the other. However, it will allow the electric field lines to pass through it. So more the amount of electric field lines passing through the dielectric medium, more would be this value of permittivity. It means it will allow more electric field lines to pass through it, and hence the name permittivity, that it will permit more number of electric field lines to pass through the medium. So better the value of this E, that is epsilon, we don't call it E, we call it epsilon, the symbol is given over here. So better the permittivity, better would be your capacitor, and better would be the capacitance of the given capacitor according to this formula. Or in a way you can say, with higher permittivity, higher would be the storage of charges on the plates, more number of charges would be stored on both the plates, allowing more number of electric field lines to pass through such dielectric medium. And this is the basic of capacitance and the capacitor. We will see more of it in the simulation ahead. Thank you.
Plate capacitor has been connected with a battery measuring voltage of 0.5 volt as seen on the voltmeter. As we go about reducing the distance between these two plates, we'll be able to see there is a change in the value of capacitance, and the value of capacitance is increasing as we reduce the distance between these two plates. If we go about moving these plates away from each other, if we increase the distance between these two plates, the value of capacitance is now reducing because there are less number of charges that are being stored on these plates when they are kept far away from each other. Now we will also see the effect of change in area with respect to capacitance. If we go about increasing the area, as you can see, with the increase in the area of plates, the capacitance is increasing and there are more number of charges stored on these plates. On the other hand, if we reduce the area of these plates, then we will see less number of charges stored on the plates and less is the value of capacitance.
The other aspect that affects the value of the capacitance is the permittivity, and permittivity is because of the dielectric medium. It is an insulating medium between these two metallic plates which might be made up of air, oil or ceramic. Now depending on the value of permittivity, because of the nature of this dielectric medium, it will also go about affecting the value of capacitance. Now for air or for free space, the permittivity is represented by epsilon 0, and it is equal to 8.854 into 10 raised to minus 12 farad per meter. However, we can also represent the relative permittivity of different mediums. So compared to air, if any medium is having twice the permittivity, the epsilon r or the relative permittivity will be equal to 2. Let's say if there is a medium which is having permittivity 10 times higher than that of free space, then it would be represented by 10. This is just the number. Epsilon r, the relative permittivity, is just the number, and epsilon 0 is 8.854 into 10 raised to minus 12 farad per meter. Now we can represent this permittivity epsilon as epsilon 0 multiplied by epsilon r. So for any other medium other than free space, we would be using epsilon is equal to epsilon 0 into epsilon r. So more the amount of electric field lines passing through this dielectric medium, better would be the permittivity and higher would be the capacitance. So capacitance increases with increase in epsilon, that is permittivity, and increase in area of the plates of the capacitor, and it also increases with decrease in the distance between two plates. So if all of this go in the same higher direction, that is increase in permittivity and increase in area along with decrease in the distance between two plates, more would be the capacitance. Vice versa, less the permittivity and less the area and greater the distance between two plates, less would be the capacitance. I hope this has helped you to understand capacitance in a better way. Thank you.